covalent bond is formed by the sharing of two electrons between two atoms. So each atom basically contributes to the formation of the bond. Electrons in these bonds are not going to stay still, but they undergo displacements. And this is either because this is either on their own or due to the presence of another species or another reagent which is, basically present. So there are four different types of electron displacement effects in covalent bonds: inductive effect, electromeric effect, hyperconjugation as well, and then resonance or mesomeric effect. So we'll be learning about all of these in the coming videos, and all of this comes under the concept of fundamental concepts in organic reaction mechanisms. So let's start with inductive effect. So inductive effect is due to the presence of an electron withdrawing group in the carbon chain. And it's a permanent effect. It's not temporary, it's permanent. And first of all, let's take the example of carbon and chlorine. When we learned about elements and their electronegativities, we learned that our halogens are more electronegative than the other elements. And so when we compare carbon and chlorine, chlorine is more electronegative than carbon. And this basically means that in the bond that is formed between carbon and chlorine, you will have electrons. Right, so there are two electrons between, and this leads to the formation of the bond. So chlorine is more electronegative, as in it can pull the electrons towards itself, and this leads to a charge difference between carbon and chlorine, and this leads to the formation of a partial negative charge on chlorine and a partial positive charge on carbon. And because this is having a partial positive charge, what this does is this will tend to pull the electrons of this bond towards it, and this leads to a partial positive charge on this carbon, that is this carbon 1, 2, 3 and 4. So this leads to a partial positive charge on the second carbon, and again of course we will expect that to happen with carbon number 3 as well as carbon number 4. So in this particular order, in these carbon atoms, the one which is farthest from the chlorine will expect the least effect of the chlorine atom. So delta 3 positive, basically that charge would be lesser than 2, which will be lesser than 1, which will be less than delta positive itself. This is because as we go farther away from the chlorine atom, the effect of the chlorine atom on the carbon will decrease, and that is why there is the decrease in the charge. Now this becomes negligible after the fourth carbon atom. So after this carbon, assume there's another carbon, the effect of the chlorine atom on this carbon will be almost negligible. So we'll only be considering the first 4 carbon atoms. And this process of displacement of electrons because of the presence of an electronegative atom in the saturated chain is called as inductive effect. So I'll just recap it. First of all, chlorine and carbon. Between chlorine and carbon, chlorine is more electronegative than carbon. So it pulls the electrons towards itself and leads to the formation of a partial negative charge. So obviously the carbon will get a partial positive charge, and what it will do is it will try making up for this partial positive charge by pulling some electrons from this second carbon, and this happens up till carbon number 4, and then after that the effect is decreased or negligible, and the charge is basically in the increasing values. So the ones which are closest, the carbon atoms which are closest to the electronegative chain or electronegative substituent, will have the most effect. So it will be more affected by the one which is far away. So by this process is known as inductive effect, and it's in a saturated, notice I'm using the word saturated carbon chain. So we're not talking about chains which have double bonds, we're talking about a saturated chain. Now there are two different types of groups which are present. Okay, they are basically electron withdrawing groups and electron releasing groups. So electron withdrawing, whereas these are electron releasing. So as their name suggests, electron withdrawing groups have the ability of pulling electrons towards them, whereas electron releasing group, they have an they will tend to release. So this is basically dependent upon hydrogen. So electron withdrawing groups have attracting power of electrons more than hydrogen, whereas electron releasing group have attracting power of electrons less than hydrogen. So they're comparing hydrogen, and electron withdrawing will have more attracting power compared to hydrogen, and electron releasing will have basically less attracting power than hydrogen. So electron withdrawing groups examples include nitro group, COOH, CN, COOR, OAR. And electron releasing would include our alkyl groups. So it can be a primary substituted, secondary alkyl, or a tertiary. Now there are two effects that we need to learn about when we talk about inductive effect. One is the minus I effect. The second is the plus I effect. So minus I and plus I. Now the main difference between these two is the kind of group the carbon chain has been attached to. So in case the substituent is electron withdrawing, that is electron pulling, then it causes the minus I effect. So I'll just write electron withdrawing group. Then of course plus I effect is caused due to an electron donating or releasing group. So electron withdrawing, so this basically means, let's assume this is a carbon chain and X is supposed to be electron withdrawing. So the electrons are shifted towards X. Okay, whereas in case of an electron releasing group, electron releasing group, the electrons are released towards these electrons are donated to the chain. Now here there are certain groups, and the order of the minus I effect is nitro group, cyanide, cyano group, acid, then you have an ester, fluorine, chlorine, iodine, hydroxy group or alcohol, and then you have a methoxy group, and then a phenyl group, and then you have hydrogen. As I told you, hydrogen is what is considered. So minus I effect is by electron withdrawing groups, and all these groups are electron withdrawing in nature. They pull the electron towards themselves. Plus I effect is caused due to electron releasing group. So CH3 thrice C shows more plus I effect. So here this basically means that this carbon is bound to 3 other carbon atoms. This is bound to 2 other carbon atoms. This is bound to just 1 carbon atom. And this shows more inductive effect than this one or the next one. That is basically an ethyl. And then you have a methyl group. So this basically means that more is the substitution, or more substituted is our alkyl chain, or rather the carbon, or rather more substituted alkane, more will be the plus I effect. So we learnt about plus I effect in this video. It's basically a permanent effect, and it is caused due to the presence of an electron withdrawing group in the end. That is, electron displacement takes place. Notice I'm not using the word electron withdrawing or releasing when we talk about the definition, because it can either be electron withdrawing or electron releasing. So in the presence of electron releasing, the electron movement is towards the carbon chain, and when it's electron withdrawing, it's towards the substituent. And plus I effect is caused due to electron releasing substituents, and minus I effect is caused due to electron withdrawing substituents. Remember, this is very important. The electron releasing and withdrawing groups part. And with that, we're done with inductive effect. In the next video, we will be discussing electronegative effect.